Now, in our last section when we looked at trig functions, we looked at a couple of questions where we had things like y equals sine 2x cosine 4x. And particularly when we needed to integrate that, we used an identity to make it something easy to work with. And actually, when we came to differentiating, we used that same identity. Actually, there's another way of doing this question. So we're going to look at what's called the product rule. So when we have two things multiplied together, then we're going to use this rule. Now, in general, this is the rule that's on the formula sheet here. So u refers to like the first term here, and v refers to the second term here. And if we want to do that, then we can find dy by dx. Now, to set up this problem, we should call this first expression u, and we should call the second expression v. So the dv means we're going to differentiate the expression as a v. So if I work out dv here, the differential for cosine is negative sine of the same thing, which is 4x, and then also the derivative of 4x is 4. So the answer would be negative 4 sine 4x. Now if I do the same thing with u, if I work out du, because that's part of the formula here, then the differential for sine is positive cosine, and derivative of 2x is 2. So I get 2 cosine 2x. Now if I use this formula then to find out what dy by dx is, so I do u dv, which is these two expressions here, and I'm going to bring the negative 4 to the front here. So sine 2x sine 4x plus v du, which is these two things times together. So 2 cosine 2x cosine 4x, and that's how we can differentiate products using the product rule. Now, if we look at our second example here, this is actually a question we answered last year and one we don't actually need the product rule for. If I was actually asking you this, you can see that it's two terms multiplied together. The difference with this question is I can actually distribute here, so I could get x to the power of 8 plus 3x to the power of 7. And then this one obviously differentiates. So if we bring the power to the front and then decrease the power by 1 and do the same with this one, then that's actually quite a simple question to answer. One question we avoided last year would be a question like this. If I switch the exponent to this term here, because now I can't simply distribute the x in here because this is raised to the power of 7. We did actually work out how to multiply out things like this using the binomial expression last year. So if you remember things like Pascal's triangle was how we started doing that section, then that would be really annoying to have to work out. So this is where the product rule is actually really useful for this type of question. So we're going to do the same setup. We're going to call the first term u, and we're going to call the second term v. We then differentiate each term. So for this one, we bring the power to the front, decrease the power by 1, and also using the chain rule, we have to times by the derivative of what's inside the parentheses. Well, that's fine for this question because it just happens to be 1, and 7 times 1 is just 7, so we'll leave it like that. So when we're doing our product rule here, we're going to do u dv, so these two terms times together, so 7x times x plus 3 to the 6, and plus v du, so these two terms times together, so 1 times this is simply just that. Now we can also do some simplifying here as well. We can't quite add these together because they're not like terms, but we can certainly take out a common factor. Certainly there's x plus 3 here. We got to the power of 6 and we have to the power of 7. So we're going to take out the lowest power, which is the power of 6, and then 7x times by this gives us this whole expression. And x plus 3 to the 6 times by x plus 3 to the 1 would give us x plus 3 to the 7, using our rules of exponents. And then if we simplify what we have inside here, 7x plus x is 8x, plus positive 3 is plus 3. So we can also use the product rule when we're using polynomial expressions too. Now, while we're using the product rule, we could also be having terms here that are trigonometric, which we just looked at in the previous chapter. And we could also have terms that are the ln function, and we could also have terms that are the exponential function. So at this point now, it's probably a good idea to review these just to make sure we can actually answer these questions. So when we differentiate the log function, what we do is we differentiate what's inside the parentheses and then write it over the original. So quite an easy question for that one. Now we could do the same thing with this using our chain rule. We could bring the 5 to the front, x plus 3 to the power of 4, divided by the original and simplify. Also remember with these types of questions, we can also use our rules of logs. So we can bring the exponent to the front, and then when we differentiate, what we can say is differential of x plus 3 is just 1 over the original, so our answer would just be 5 over x plus 3. Now the exponential function is also very simple to do as well. We're going to differentiate what the exponent is, so 3x plus 2, so the differential of that would just be 3, and then we just copy down this same thing again, e to the 3x plus 2. So if we're doing this one, differential of negative x would be negative 1, and then the whole thing again, e to the negative x. So just a little reminder on how to differentiate the exponential and log function, because you'll be using those certainly in this exercise too.